My name is Elise, Birde, and I'm here to present on the Break Free from Plastics Act of 2021. Before I get started, I want to take a minute to thank my team, with a special thanks to Amy Cowitz, Max Gladby, and Aiden McKean this week. I'd also like to thank our advisor, Dr. Cook. So why are we talking about plastics? There's several problems with the plastic life cycle. Everything from production and consumption all the way to waste management, as you can see here. This is a picture from the Philippines, which is actually one of the countries that the United States exports our plastic waste to. To understand the full scope of the plastics problem, we have to go back to the 1940s when fracking was invented. Fracking is the process of injecting hydraulic fluid into the Earth's core to extract the oil and gas out there. As a result of this innovation, we had a supply glut. At the same time, analysts were predicting that the demand for fuel was going to go down. This led petrochemical companies to make a push into the plastics market. And we can see that in the remnants of the mass production and consumption that we have today. Plastics is particularly advantageous from a manufacturing perspective because it's both durable and cheap to produce. Looking to the future, we expect the demand for plastics to double by 2030. This is problematic because petrochemical companies are using this as a justification to continue the exploration and extraction of oil. Additionally, it's a problem because the largest market for plastics is in single-use plastics, which creates an issue on the waste management side of things. As we move through the rest of this presentation, we're going to talk about how some greenhouse gases are emitted and how plastic leads to a pollution problem. So looking at the plastics life cycle, you can see that it begins with extraction, and then it moves through the refinement and cracking stages, which creates the products to make raw plastic, which are called nurdles. So nurdles are little pellets of plastics that can be used to make the final product. The final product is then distributed all around the world using ocean, air, and land transportation. It's then consumed and it becomes waste. Once it enters the waste management system, we see that it can become three types of waste. It's either recycled, it's reused, or it ends up in a landfill as waste. So I'd like to highlight a few things on this slide. Most importantly, this is a fracking device in the middle, the giant red tower. And it creates fractures in the Earth's core where the oil is, and that's how it extracts all the oil and gas from the ground. As a result of the fracking and the fractures that it's creating and injecting the hydraulic fluid in, you can see how that it would easily seep into the neighboring communities' water supplies all the way on the left side. So for the next few slides, I'm going to focus on some of the health and environmental concerns of the production of plastics. So when we think about the environmental consequences of plastic, it really starts with the extraction process. So during extraction, methane is released both accidentally and intentionally. Methane is particularly problematic from a greenhouse gas perspective because it's 80 times more potent than carbon dioxide. Other emissions and toxic spills are also happen all throughout the plastics production life cycle, everything from extraction and manufacturing to the distribution of nurdles. We see that this causes air, land, and ocean pollution. This is an example of the aftermath of nurdle spills. So nurdles are those raw plastic pellets that I mentioned earlier, and as you can see, they're really tiny and they look like fish food. So oftentimes fish can consume nurdles thinking that they're food, and they end up malnourished because their bodies aren't able to digest them. When we turn to the public health effects of plastic production, we see that chemical facilities are releasing hazardous air pollutants into the air. HAPs are tracked by the federal government because they're known carcinogens. A recent study suggested that COVID mortality rates were correlated with higher exposure to HAPs. Another hazardous health effect of the production of plastic is the use of BPAs and phthalates in production of plastic. BPAs and phthalates make plastics more durable, so they're advantageous from a production perspective. However, they're detrimental to our health. Recent legislation went into effect to ban using BPA and phthalates because of their toxic effect on people. Other toxic chemicals are released into the air that are linked to cancer and asthma all throughout the production process. As we look at the second half of the production life cycle, the plastic life cycle, we can see that we're only going to focus on waste today. In future presentations, we'll talk a little bit more about the recycling and reuse side of things. So there are several environmental consequences of waste. This largely stems from the fact that only 91% of plastic is recycled. Or is, excuse me, I'm sorry, 91% of plastic is not recycled, so only 9% of plastic is recycled, which means that 91% of plastic is ending up in landfills and the ocean. So landfill plastics are particularly problematic because 80% of landfills have leaks, which means that those chemicals are then being leaked out through the ground to local water and soil supplies. So plastics, as they decompose, also emit greenhouse gases and other toxins into the atmosphere. Ocean pollution has another side of the plastic waste management process. The ocean pollution is linked to a decrease in biodiversity and an increase in spread of disease among marine life. Ocean plastic is also consumed by marine animals. So I mentioned earlier how fish would eat nurdles, but they also consume microplastics, which are fragments of plastic smaller than 5 millimeters that result from the breakdown of plastic. Microplastics end up bioaccumulating in the food chain, which means smaller fish are eating microplastics, then bigger fish are eating those fish, and then humans are consuming those fish, which means that so the bioaccumulation of microplastics is leading to health concerns in the human population. We see that microplastics act as endocrine disruptors in the body. So endocrine disruptors affect our body's ability to produce natural hormones that are vital to life. Microplastics are also associated with inflammation and DNA damage. The full toxic effects of microplastics are not fully understood, and research is currently being done to fully understand how this will impact all of human health. BPAs and phthalates, as I mentioned earlier, were recently banned. These are both types of microplastics. We've talked a lot about the public health effects of plastic production and waste. Now we'd like to focus a little bit more on who is actually impacted by this process. The socioeconomically disadvantaged communities are more likely to be impacted by the plastic production and waste management problem. We see that oil fields are located on tribal lands, which means as we're emitting toxins into the air and the land, their communities are most likely to be impacted. Fence-line communities are located near petrochemical and other chemical facilities. People of color are twice as likely to live within petrochemical fence-line communities and twice as likely to be exposed to the harmful chemicals that they're producing. We also see that there's a disproportionately higher risk to toxic chemicals in the air. Higher rates of cancer and asthma are seen, and as we look to Louisiana's Cancer Alley, we can see an example of how a community that's surrounded by over 200 petrochemical facilities see much higher rates of cancer and asthma. Another example of how the plastic problem disproportionately impacts socioeconomically disadvantaged communities is that waste dumps and incineration sites are located in low-income communities of color. When we look to the solution to this problem, this bill is going to address three core issues of the plastic problem. The first is plastic waste overproduction and consumption. We'll address this by extending producer responsibility and banning single-use plastics and papers. We will also be reducing other sources of plastic in the environment. Another way that this bill is going to address the plastic problem is by standardizing recycling and composting practices. The last way that this bill is going to address the plastic problem is through technology and research. So we will be increasing local government efforts using social media to target exactly where waste production is. As a result, we'll be able to actually get involved in the communities and start grassroots movements as opposed to just coming in as big government. The last way that we will address the core plastic problem is through funding for innovative projects. We're going to focus on answering questions like, can we take microplastics out of the ocean? And is it possible to make plastics that don't decompose into microplastics? Every week, we consume 1 credit card's worth of plastic. Throughout this presentation, we discussed many of the health concerns associated with microplastics and the plastic life cycle altogether. I hope you agree that this is pressing legislation that we need to get passed. In the next few weeks, we'll be discussing more of the solutions that we're proposing in this bill. Thank you very much for your time. Are there any questions at this time?
I'm curious about when you mentioned, first of all, breakdown. Excellent. When you mentioned that the breakdown of plastics emits gases in and of itself, is that through the incineration of plastics that you're destroying them, or is it the actual breakdown cycle of plastic that emits that?
So the question was whether as plastics decompose, they also emit greenhouse gases, or it's through incineration. So it's actually through both, because plastics are a byproduct of fossil fuels. There are some like petrochemicals that are emitted when they kind of decompose. I didn't mention it, but plastics take anywhere from like 50 to 600 years to decompose. So it's like a really slow process of that coming through, but in aggregate, that's a pretty big impact.
Does microplastic pollution have a disproportionate impact on complex communities due to access to healthier food, or is that pretty, not that we can see in the but that's pretty much the same across?
So it's a global average. Oh, I'm sorry. So the question was whether the microplastic consumption is seen disproportionately in socioeconomically disadvantaged communities, or if that's across. My understanding is that statistic is a global average, so that's looking at communities that are more likely to consume fish, averaged also with communities that are less likely to consume fish. Like obviously island nations and stuff like that do a lot more fish, and kind of the way the microplastics are spread, we see them all the way in the Arctic and the polar, so it kind of impacts everyone. Yeah.
What are the consequences of microplastics leaking into soils?
Yeah, so oh yeah, I keep doing that. So Kayla's question was speaking more to the way that microplastics are leaking into the soils. So when there's leaks in soils and it rains and there's a bunch of plastic sitting there, the plastic just sits in the water, effectively like plastics in oceans. And then those leaks in the liners leads to it like just falling into the local soil and continuing to contaminate that. So we see that areas where there's like more rain, that's more likely to happen.